Greetings everyone. Welcome to another session of Circuits and Systems. In today's lecture, we are going to start with the operations on signals. So what we are going to go through, we are going to go through with the basic operations on the signal, and then we are going to go with the multiple operations on the signal and we have to plot them. At times in exam, they give you a signal and they want to plot something with a delayed version or an advanced version or a scaled version. So that is operation on the signal. So always remember, my dear friends, you cannot change your future, but you can surely change your habit, and surely your habit will change your future. So you just need to change one habit, come out of your comfort zone, start practicing hard. So let's move to today's lecture. So first, we are going to see the basic operation. So there are three basic operations on a signal. Either we are shifting the signal, we are scaling the signal, we are expanding it, or we are squeezing it, or we are reversing the signal. So the first basic operation is time shift. So what does this time shift says? The time shift says if I have a signal x of t and I shift this signal by minus t units. So this means that my signal is being shifted towards right by t units. Okay. Similarly, we have a signal xt and we can shift it as plus t. This will shift my signal towards my left side, left by t units. Okay. So this is basically shifting of signal, advancing it or delaying it. There is a trick to it. Always remember which side it has to shift, with minus right, with plus left, whatever it is. So what you can do is you just remember this trick. X of t, you always want to have this minus sign over here, and then whatever the shift is given to you. Okay, let us say if the shift is given, let us say there is some xt. Okay, this is your xt starting from minus 1 ending at 1. You want to shift this xt, you have to plot xt minus 2. So simply keep a minus sign over here and you have to maintain this. For maintaining this, you have to write down plus 2. Is it clear? Now, if you're writing it down plus 2, then the equation reads x of t minus 2. This is what we want to plot. And what does this plus 2 signifies? This plus 2 signifies shift this 0 origin to its plus 2. So when the 0 origin is shifted to plus 2, the wave will start from plus 1 and it will go to plus 3. So this is how shifting is done. Then the second operation is reversal. We have been given x of t. I need x of minus t. This we saw during even and odd signals as well. So what it is, this operation is simply, let us say, I have this signal starting from minus 1, 0, moving to 1. This is 2. This is x of t. Now, what does reversal says? Reversal says hold your axis, hold your axis and just rotate it on it. Hold your axis and just rotate it on it. So this point will go something like this. And values will remain as it is. 0, this will be minus 1, this will be minus 2. So what was at 2 has gone to minus 2, what was at 1 has gone to minus 1, 0 remains as it is, and what was at minus 1 goes to plus 1. So this is reversal. The last of operation in time domain is scaling. So they have given us x of t. I want to plot x of 80. Now always remember, while we are plotting the scaling signal, where it is having a multiplication factor of coefficient a, when it is multiplication of with coefficient a, then my signal is going to get squeezed up. It is going to get squeezed up. Whereas when x of t will be x of t by a, my signal is going to get expanded. Like say, for an example, -1, okay, put it -2 plus 2, amplitude is still 1. So I want to plot x of 2t of it. What it would be? This whole signal will be squeezed by 2, that is from -1 to +1. Amplitude still remains same, and this will become x of 2t. And otherwise, if I have to plot x of 1 by 2t, then the signal will expand from -4 to 4 and amplitude still remains 1. This becomes x of 1 by 2 t. So these are the three basic operations. Now the point is, at times in exams, all three operations are combined in one signal and they'll ask you to plot it. Now there has to be an order for it. So what is the order? The order says first you shift, then you scale, and then you reverse. Okay. There are some text which says reverse shift scale, whatever it is. Now, point is, I don't want you to remember this thing. Just go with your mathematical instinct. So let us say this is the given signal. This is one of the signal which has been given for synthesis in your exam. Okay. So I'm using it on operations. So this is one of the signal and they have asked us to plot f of, they've asked us to plot f of 2. Now remember this thing. This is amplitude scaling. This is not on time. F of 2t, this becomes my time scaling, minus 3, this is time shifting. So there are three operations: amplitude scaling, and time shifting. So please remember, this amplitude scaling has got nothing to do with what's happening in time. Amplitude scaling will just increase this amplitude from 4 to 2, from -4 to -4 to 8, and -4 to -8. So amplitude scaling has nothing to do with. Now the trick is over here. How to solve this? Simply just do one thing. See, you have got all the values for t. T is 0, T is 2, T is 4. So we have got the values for t. So just do one thing. Put it t is equals to, replace this t with a dummy variable 2p minus 3. Clear? So now get everything in terms of p. So p is equals to t plus 3 divided by 2. This becomes my p. Okay. So what I've done, I've just replaced this t with the dummy variable p. Now I'm writing t is equals to 2p minus 3. Formulate a table. Formulate a simple table. Get the values of t, put the values of t, get the values of p. So t is varying at 0, 2, and 4. So t is 0, 2, and 4. Substitute the values. Put t is equals to 0. When t is equals to 0, 0 plus 3 is 3. 3 divided by 2 is 1.5. Put t is equals to 2. 2 plus 3 divided by 2 is going to give me 2.5. And what is at t is equals to 4? 4 plus 3, 7. 7 plus 2. 7 plus 3 is, no. Yeah, 4 plus 3 is 7. 7 divided by 2 is 3.5. Now simply what you have to do is get the same graph. Get the same graph. What is at 0? What is at t is equals to 0? Plot it at t is equals to 1.5. So let's say this point is 1.5. Got it? We have got the first point. We are going to match the 0 to this 1.5. What is at 2 will be matched to 2.5. Put it 2.5. So what was at 2? At 2 the value was 4. Multiply by this 2 will give me 8. Now let's see. Let's put this thing as 8. And there's another value minus 8 at the same point. So let's say this is minus 8. So I've got the value at 2.5 and this. And whatever it was at 4 plotted at 3.5. So this is 3.5. So this is f 2t minus 3 whole is equal to this. Now here, I don't have to remember whether I have to shift left, whether I have to shift right, when I have to reverse, when I have to scale. Simply, mathematically, I've solved this. Let us try another one. There is another function given to me. So it is minus t plus 3 divided by 2. Again, what I'll do, I'll put t is equals to minus p plus 3 divided by 2. 2 will go there, minus 3 will come here. So my p will be 2t minus 3. So it would be 3 minus 2t because minus sign will be there. So p will be 3 minus 2t. 2 will go here, 3 will come here, minus 3, minus sign. With minus sign, 3 will become positive and this will become like this. Again, plot a simply just plot a table. Put t, get the value of p. So t is 0, 2 and 4. So whatever is at 0, put it 0 will be coming at 3. Whatever is at 2, 2 into 2, 4. 4 minus 3 is minus 1. 4, 4 into 2, 8. 8 minus 3 is minus 5. Now see, there was an operation of reversal. There was an operation of scaling. There was an operation of shifting. All three done in one go. So whatever was at 0, plotted at 3. This is 3. I've got my first point. Whatever was at 2, plotted at minus 1. So this is minus 1, plotted like this. Whatever was at 4, plotted at minus 5. So let's say this point is minus 1, this point is minus 5. I've got my signal ready. This is t, this is f of minus t plus 3 by 2. Simply, the thing is done. Do try this at your home. It's t plus 3 divided by 2. So these are the operations. These are the multiple operations what we perform on a signal. So moving ahead, let's try one on the case of discrete. Now, how to plot this discrete? See, always remember, this arrow tells you the position of your axis. So 0, minus 1, minus 2, minus 3, 1, 2, 3, 4, 5, 6, 7, 8. Let us see how many samples are given to us. So at minus 1, the value of sample is 1. 2, it's 1. Here it is minus 1, plus 1, minus 2, plus 2, plus 3, and minus 3. So I'll just write down the value of the sample on the top. 1, minus 1, 1, minus 2, 2, 3, minus 3. Now, there's just one simple catch to it. Okay, there's one simple catch to it. What's that catch? Let's solve this one. Okay, what is given to us? It's minus n minus 3 divided by 2. Substitute this n by p. Put it, because I've got the values of n with me. So put it like this. So minus p minus 3 is equals to 2n minus p is equals to 2n plus 3. So p is equals to 3 minus 2n. Okay. Uh, okay. Let us just consider one more thing. What I wanted to discuss was will not come here. Okay. Still. So simply substitute the value of n. You'll get the value of p. Plot the signals. Substitute the value of n. You'll get the value of p. N is from minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5, 6. So when you'll put substitute minus 3 into minus 2 is going to give me plus 6 plus 3 will give me 9. minus 2, 4, 4 plus 3, 7, minus 1, minus 2 is going to give me 5. Then I'll be getting 3, I'll be getting 1, minus 1, minus 3 into 2 is 5, then 3 into 2 is 6, then I'll be getting minus 3, minus 5. Similarly, I'll be getting minus 7 and minus 9. So this is how you can plot. Now my point was a bit different. So let us just try with this one. 2n minus 3, put it 2p minus 3 is equals to n. Yeah, 2p is equals to n plus 3. So p is equals to n plus 3 divided by 2. Now there is a catch over here. What's the catch? You have to just see it carefully. Put it n, put it p. Substitute the value of n from minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5, 6. These are the values. Substitute the value of n. Minus 3 plus 3 is going to give me 0. Agreed. Minus 2 plus 3 is going to give me 1 by 2. And I am not going to plot this sample. Okay. Any sample coming at a non-integer value of n will not be plotted. So that sample will be omitted. Okay. Put minus 1 plus 3. 2 divided by 2 is going to give me 1. Put 0. The sample is not going to get plotted. Put 1. 1 plus 3. This will be 2. 2 plus 3, 5. 5 divided by 2 is not going to be plotted. 3 plus 3, 6. 6 divided by 2 is 3. It would be plotted. 4 plus 3, 7. No. 5 plus 3, 8. I'll just clean some. So 4 plus 3, 7. This sample won't be there. 5 plus 3, 8 will be 4. 6 plus 3, 9 won't be there. So in this case, sample at minus 3 was 1. This will be plotted at 0. Sample at minus 1 was 1, will be plotted at 1. Sample at 3, that is minus 2, will sample at 1 will be plotted at 2, minus 1. Sample at 3 will be plotted at 3, that was minus 2, 1, 1. Sample at 5 will be plotted at 4. What was sample at 5? Was 3, will be plotted at 4. And sample at 6 won't be plotted. So this is the result line. So just take care, in the case of discrete time, no sample will be plotted if the value of time is coming to be a non-integer value. Clear everyone? So just remember this thing, plot this table, put a dummy variable, you'll get all your answers. You need not have to remember shift right, shift left, going this, going that way, just the table. So great acts are made up of small deeds. So one of the small deed is just practice the small questions. Small questions will get you good marks. Marks from each question will get you great marks in the subject. And one more thing, like, share and subscribe the channel. That is again your small deed, but that is going to help greatly to grow the universe. Thank you all. Thank you.